In this video, we're going to look at how radicals actually fit into exponential functions other than being used on occasion to solve them. In fact, we can take any radical and write them as an exponential function themselves. And so we look here at this top little table where I kind of have the process laid out. So if I had the square root of a, now remember the square root is really the second root of a. And I could rewrite that as what is inside the radical being raised to the 1/2 power. Likewise, the cubed root, so I have my radical, and then the power of the radical is 3, being applied to what's on the inside, and on the inside is a. So the third root of a is the same thing as a being raised to the 1/3 power. So you might start to see a pattern here with the way the exponents went. I had second root, I had a bottom number of 2 as the exponent. Third root, bottom number of 3 as the exponent. So if I had any powered root, call that n. So if I had the nth root of a, I could rewrite that problem as a raised to the 1/n power. Now, the bigger question is what happens if I have an exponent inside of my radical? So let's say I had a to the m. Well, I could still write that as a to an exponent. The power of the root always goes in the denominator of the exponent, and the power that's applied to a goes on top. So the nth root of a to the m power can be written as a raised to the m/n as its exponent. And so let's do a couple of conversions here. So let's convert the 7th root of x to the 4th power into exponential form. So we're going to write this as x raised to a power. Now, the power of the radical, which is 7, goes in the denominator, and the power that's applied to the exponential function goes on top. So that's the same thing as having x to the 4/7 power. Likewise, let's look at the next one, the 5th root of x to the 3rd power. I'm going to write that as x to an exponent. The power of the radical goes on the denominator, so the denominator of that exponent is 5. The power that is applied to the inside, the cube, will go on top. So the 5th root of x to the 3rd power is the same thing as x to the 3/5. Now I want to go the other direction, so I want to convert into radical form. So we're given the exponential expression that has a fraction as its exponent, which means that if I see a fraction as an exponent, I can write it as a radical. And so we're going to take x, and we're going to put x inside the radical. Now I got to figure out how my numbers work out. The number on the top becomes the exponent on the inside. The number on the bottom becomes the power of the root. So I have the second root of x to the 1 power. Now, I don't write the exponent of 1, so it's just x on the inside. And I don't write the power of 2 for a root because we can just write that as the squared root. And so here's my answer. Now let's do the same thing for x to the 5/6 power. So I'm going to write this in radical form. So I'm going to write my radical, and I'll put x on the inside. Now the number on the bottom is the power of the root. So 6 is the power of my root. So 6 goes right up here in the corner of the radical. And the number on the top, the 5, is the exponent that is applied to what's on the inside. So I have the 6th root of x to the 5th power. Now we want to use those skills that we just did to simplify some of these exponential expressions that involve exponential functions and radicals. So to do this, we're going to need to rewrite everything in exponential form and then apply our property of exponents. So we'll look here at this first problem. In order to simplify everything to be in the exponent of just an x, I need to first rewrite the cubed root of x. Now, when I rewrite the cubed root of x, remember that's the same thing as x being raised to the 1/3 power. And I write everything else that I have around it, so that's multiplying to x to the 4th to the 1/3. Now we use properties of exponents. We have power to power. Power to power we multiply. So that first part becomes x to the 4/3 power times x to the 1/3 power. Now we're looking and we multiply like bases. When you multiply like bases, you add the exponents together. So that's going to make x to the 4/3 plus 1/3 power, which makes 5 over 3. And they wanted us to solve for a. So that is really x to the 5/3 is equal to x to the a power. That means a is equal to 5 over 3. Okay, let's look at another one here. So I have x to the 1/5 squared times the 5th root of x to the 6th power. And I want to put all that together, and so that way I just have it in the form of x to the a. Well, step one, rewrite the radical in exponential form. So the 5th root of x to the 6th power would be x to the fraction exponent of 6 over 5. So the power of the radical goes on the bottom. And then I'm going to write everything else that I have. So I still have the x to the 1/5 squared. Now it's properties of exponents. So power to power, multiply our exponents together. So that makes x to the 2 over 5 power times x to the 6 over 5 power. Now when you multiply like bases, you add the exponents together. So I'm going to add the 2/5 and the 6/5 together. That gives me x to the 8 over 5 power. So x to the 8 over 5 power is equal to x to the a. And they want us to write what a is, so a is that exponent. A is equal to 8 over 5. Okay, looking at this one, this time I have division. And the process is still the same. I want to get everything and simplify it to be just x to the a power. I need to write this radical as a fraction exponent. And so when I do that, I have x over the squared root, say there's no number there, but it's an implied second root, is equal, the square root of x to the 5th is the same thing as x to the 5/2 power. And I got equals x to the a. So we're trying to get everything crammed up here. Now, we are dividing like bases. When you divide like bases, you subtract the exponents, top minus the bottom. So we'd have x raised to the 1 minus 5/2 power is equal to x to the a. Well, I need to do 1 minus 5 over 2. In order to do that, I have to have common denominators. So 1 is 2 over 2. So 2 over 2 minus 5 over 2, it gives me negative 3 over 2. And so what we have is we have x to the negative 3 over 2 power is equal to x to the a. Now, I don't simplify this any farther. I don't make that exponent positive by moving it to the denominator here because I wanted it in that form. So a is equal to negative 3 over 2. Okay, last one here. So I have division again. I have x to the 3rd divided by the square root of x, and I want it combined and simplified in the form of x to the a power. We start by rewriting the squared root as x raised to a power. So we have x to the 3rd on top over the squared root. So that exponent of that x is a 1. The power of that root is a 2. So the squared root is the same thing as x to the 1/2 power. Now we're dividing like bases. We use our properties of exponents. When you divide like bases, you subtract your exponents. So it becomes x to the 3 minus 1/2 power is equal to x to the a. Well, I just need to do 3 minus 1/2. I have to have common denominators. So 3 is the same thing as 6 over 2 minus 1 over 2 gives me 5 over 2. So my left side of my equation is x to the 5 over 2 power is equal to x to the a. So that tells us that a is equal to 5/2.